Many people have heard of nuclear energy. However, people may associate this word with bad meanings. What comes to mind are nuclear explosions, meltdowns, etc. But I am here today to explain the potential benefits of nuclear energy. Many people often wonder where the word nuclear comes from and what it means. It comes from the word nucleus, and in this case it's referring to an atom. Atoms are building blocks of materials that consist of a proton with a positive charge, a neutron with no charge, and an orbiting electron with a negative charge. The overall charge of an atom is zero, since the protons balance the electrons. The neutrons have no charge. Atoms can store energy, in which we call in this example potential energy. The bonds in an atom are what contain the energy, and when these bonds are broken, they release it. Nuclear energy is harvested through a process called nuclear fission. Fission is a word that basically means to split. In the process of nuclear fission, a certain atom is induced to split, and as it's splitting, it releases energy. Now, an atom with a specific number of protons is referred to as an element. And in the case of nuclear fission, we're going to be dealing with uranium-235. The 235 is an isotope of uranium, and an isotope is the same element but with a varying number of neutrons. Uranium naturally undergoes fission, only at a very slow rate, so it makes it easy to induce fission, obtaining the energy stored in its bonds. Uranium naturally goes through a process called alpha decay. In this process, the uranium atom throws off an alpha particle, which is 2 protons and 2 neutrons bonded together. And as it releases this atom, it releases energy in the form of gamma rays. You may not have heard of gamma rays, but I'm sure you've heard of things like X-rays and radio waves, which are all in the same electromagnetic radiation scale. The difference is they have varying amounts of energy, which is corresponded to their frequency or number of waves in X amount of distance or time. Now, gamma waves have a relatively high frequency, so they have lots of energy. But compared to radio waves, which are constantly going through us, have a low amount of energy. Since uranium naturally undergoes fission, it makes it fairly easy to induce fission. And this is done by introducing a neutron into the target nucleus, in this case uranium. Now, uranium captures this neutron, and it's going to split into several products. It splits into smaller atoms, releasing energy, and it also releases more neutrons, which is a very critical step, because these other neutrons will go on to act on other target nuclei, and they will continue to make fission products. So the process is self-sustaining once it reaches a point called critical mass. This is a diagram of the chain reaction that results from nuclear fission. So this would be the first generation. The neutron is introduced to the first uranium atom, and other uranium atoms are waiting to capture a neutron. So once the neutron and energy are released, this neutron acts upon this atom, and this atom causes it to split, releasing more neutrons, which causes this atom and this atom to split with these. So you can see it follows an exponential equation. And exponential equations quickly add up. I would like to add a side note here using an application of the equation energy equals mc squared. Almost everyone has heard of this equation, but not everyone has heard of its application, but it's very applicable to nuclear energy. In this case, some of the mass of the atoms is actually lost. Now you're thinking, how can this be true, and does this contradict the law of conservation of mass? Well, no, it doesn't, because it's simply converted into energy. And you can see that mass is multiplied by the speed of light. That is a huge, huge number. So loss of mass, it's not actually a loss, but a transfer of mass is going to yield an incredible amount of energy. Now you're probably wondering, how can this energy be harvested? Most of the energy ends up as heat. And this is the main component of harvesting nuclear energy. You may not have known that the idea of nuclear power plant is very similar to burning coal. Both heat up water to produce steam to turn a turbine in order to generate electricity. Now that we understand nuclear power on the atomic level, we need to move on to the nuclear power plant in order to fully understand how the energy is converted into electricity. So to begin, uranium must be mined and then purified. It is then arranged into 2.5-inch dime diameter pellets, which are then arranged into long rods, which are bundled together and submerged into water here. Now this water acts as a precautionary measure in order to prevent overheating and nuclear meltdown. And this is also the site of nuclear fission. So, as fission is occurring, heat is being produced, which heats this water, converts it to steam, travels through the pipe, turns the turbine, which turns the generator, generating electricity. Now this water condenses and moves on to the cooling tower, where it can cool at a safe rate, and then the water is recycled back into the cycle for it to begin again. Next, I would like to talk about the precautionary measures taken in order to prevent nuclear meltdowns. And they mostly occur right here in this general place called the reactor core. So first, there are things called control rods that can control the rate of fission. By lowering and raising these rods, it can absorb extra neutrons produced in fission. Next, we have a concrete liner around the pressure vessel. And this serves as a radiation shield because a byproduct of fission is radiation. So this absorbs the extra radiation. Next, we have a steel liner inside. It surrounds the reactor core, and this can prevent the leakage of gases and fluids. Finally, we have an outer concrete structure that surrounds the steel liner, and this can deal with large amounts of mechanical energy possibly caused by earthquakes or tsunamis, etc. And this was missing in Chernobyl, and that is why a nuclear meltdown occurred. And sadly today, that often resonates with people who have those images stuck in their head. However, many things are done in order to keep these reactors safe, and they are constantly monitored and highly controlled. There are many pros and cons to nuclear energy. One of the pros is that nuclear energy is independent of fossil fuels. CO2 emissions are also minimal in nuclear power plants. But the big pro to nuclear energy is the incredible amount of energy produced. Now, a pound of highly enriched uranium is equivalent to the power of 3 million gallons of gasoline, which is an amazing statistic when you look at it. Now the cons of this are the waste products of the uranium rods. These rods emit radiation and take over 10,000 years to naturally reach a safe level. They must be mixed with glass and stored in concrete structures for years and years. And also, radiation waste is on parts and equipment, which cannot be healthy for human beings. The mining and purification process costs money. Storing these rods costs money. However, the cost of this can be easily paid off by the amount of energy produced. And obviously, the last con is always the fear of a nuclear meltdown, but this can easily be avoided with proper control of a nuclear power plant. In conclusion, nuclear power is an amazing feat of science and technology. Through the process of fission, the energy stored in atoms is released and harnessed in order to produce electricity. Although nuclear energy is not perfect, it is a great source of alternative energy. In the near future, if more research is done in order to rid ourselves of these waste products and control nuclear meltdowns, nuclear energy will be one of the top energy sources of the world.